Okay, so since there's no problems, we'll just continue. Oh, let me write down, sorry. We are missing Jason. What's today's date? 15th. Okay. Oh, I'm already forgetting your names. It's terrible. Abdul Rahman, Marwan, Kayhan, Jeffrey, Abdul Ali. Okay, good. That table, good. Full marks. This table, Son, Peter, Dami, Daniel? David. I knew it was a D. And me. Yeah. Okay. And we're missing Jason. Right? Yeah. We do have a David, don't we? I mean, we do have a... No, Daniel moved.
Yeah.
And who else moved? Someone else moved, no? Gabriel moved? Yeah. Okay. Can you write that down? That's what we'll have a look at now. Resolving vectors. You got that? Yep. Continue. Resolving vectors. Okay. You know these words, don't you? Horizontal and vertical? Yeah. Which is horizontal? Which way? And vertical? That way. Okay. Did you all know that? Ming, did you know that?
Yeah.
Are you sure? Which is vertical? Show me which is vertical. And horizontal?
Yeah.
Okay, good. Right. So horizontal and vertical vectors can be added just like any two vectors. And this is a common problem in mechanics. But so is the reverse. That is, taking a vector and writing it as the sum of a horizontal and a vertical vector. So what I mean here is you can have a vector h, you can have a vector v, and you can add them together. So that would be h plus v, and there's the result. We did that last time.
Yeah.
But what we want to look at today is the opposite. So this is what we mean when we say to resolve, is when we take a vector like this, but go backwards and write it as a horizontal plus a vertical. That's our job for today. So it might be a good idea just to actually draw this to help you remember the word resolve. Resolve, noun, verb, what do you think? The verb, yeah. What's the noun? Well, if resolve is the verb, what will be the noun, by the way?
Resolve also.
Is it?
Resolvation.
Say again?
Resolve also.
No, hang on, say again?
Resolvation.
Oh, close. 90%. Not perfect, though. Anyone else want to try?
Resolution.
There we go. Resolution. Yeah. So if you resolve something, then you have a resolution. Yeah? Yes?
That's
Yeah? So here you could say to resolve vector or, well, this is the resolution, but we don't really use that word in physics. There's a different word, a different noun, So does anybody know maybe the noun to describe the H and the V here? So normally in English we would say resolution, like you said. But in physics we have a different word here. Does anyone know it?
Component.
That's it, components. So when we say resolve as the verb, components is the noun. Okay. So this is called the horizontal component and this is called the vertical component. Yeah? Is component's a word you knew? Did most of you know the word component? Marwan, you're looking like maybe you didn't. Yeah. What about resolve? Is that a new word? Marwan? No, you knew resolve before? You're not looking so sure.
I'm not sure.
Okay. Right, continue? Yeah. So, some things that will help us in this lesson is Pythagoras. You all know Pythagoras. How old were you when you first learned Pythagoras? I think maybe 12? Yeah? Maybe 15? Between 12 and 15? It's a while ago. So this is Pythagoras Theorem. A squared equals B squared plus C squared. I think in most languages it's still Pythagoras or Pythagoras. Except for Chinese, where it's something like, I don't know, what's it, Gogodi or something? What's this called in Chinese? Yeah, or something like this. I knew it was something like this, yeah. But in Arabic it's Pythagoras, isn't it? Yeah, same thing. Yeah. Oh yeah, what's the name of this triangle? Right angle triangle, yeah. Continue? Yeah. This is useful for finding the magnitude. Right, here is a very simple one. I think it'll only take you a few seconds. What is the magnitude of the resultant of 3 meters east and 4 meters north? So by using Pythagoras, we get 5 meters northeasterly, roughly. But it's just the magnitude, so it's 5 meters. And this reminds us of the famous triangle called the 3-4-5 triangle as well. Yeah? Okay. These sides have names which you might not know. So if this is the direction, the angle here, we call this side the opposite because it's opposite the angle. This side we call adjacent, and this side we call hypotenuse. Ming, I bet you didn't know these words.
Yes.
These are new words.
Yeah.
Marwan, new or old? I say new.
Yeah.
Yeah, I think so. Yeah. Well, I'm sure you knew opposite. Yeah. Yeah.
Well, he knew it is.
I knew it too.
The names. Yeah, I would think most people would. I would hope everyone knew opposite. Now just be careful. If the theta, this is a Greek letter, theta, if the theta is up here, what changes?
Opposite.
Yeah, opposite and adjacent swap places. But the hypotenuse is always the hypotenuse. Okay, you definitely want to write those words down. So son, how many boxes of chocolate did you get in Switzerland? Like 10?
Probably around 15.
15, nice. Nice. One per day? Or what's your plan? How many per day?
No.
One per day? One per 2 days? One per week? What's your plan?
I remember.
Like, yeah. How long do you want the chocolates to last? That's my question.
No idea.
No idea, okay.
Depends on the height.
Yes. How happy or sad you are, maybe. Alright, you got that?
Yes.
Yeah? Okay. Now, you haven't done this in maths yet, but we can use what's called tan inverse to get the direction. So if you know the opposite and the adjacent, okay, it's possible to know this theta here by typing in on the calculator tan inverse opposite over adjacent. And I just want to show you that on the calculator here. Now, in the last class, if you look at the 3, 4, 5 triangle, what was the theta? What was the angle beside the 3? Have a look, please. Tell me what it was.
What was the angle?
Beside the between the 3 and the 5 side.
53.13.
Okay. So look, if that's 3, oh, and sorry, what was the other angle actually?
That's a
36.87.
Right. So if that's 3, and that's 4, and that's 5, then between the 4 and the 5, you said it was 30.
6.8.
Okay, let's check that. So what you do is you type in this. Shift tan 3 over 4. Oh, sorry, wrong mode. This is what it was. But if you want this angle up here, what would you type in?
3 over 5.
If you're using tan.
Oh, 10 is like 3.
So it'd be 4 over 3. Which is what I have in the question.
Yes.
Yeah? Okay, so you want to make note of this useful formula. Yeah. You got that? Continue? Yep. Right. I've actually done it. What's the direction here? So I would have to type in tan inverse. What? What do I type in? 4 over 3. Tan inverse 4 over 3. Which is this. So tell me how I would give the answer using north, south, east, west. So the direction is,
53.13.
yeah,
East.
not quite.
North of east.
North of east. 53.13 north of east. Yeah? Yeah? Or another way you could say it is east 53.13 north. Yeah? Okay, continue. Yeah? Yeah. Right, now there's actually 2 others that are useful here, sine, cos and tan. So sine theta is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. Often we know the hypotenuse and the angle, and I'll show you what we can do with that piece of information. Before we continue, I would like you to draw this. Okay, you got that drawn? You all have that drawn? Yeah. Right, so let me give you something that's useful here. So let's imagine I tell you this side, or the magnitude, okay? And I would like to know this side, h, and this side, v. And I also know theta, okay? You can say sine theta equals v over r. Therefore, v equals r sine theta. You can also say cos theta equals h over r. Therefore, r equals h cos theta. So in other words, if I give you this vector with this angle and this magnitude, you can quickly say that this side will equal r cos theta and this side or sine theta. And the way you can remember is try to remember cos goes with the theta and sine goes with the opposite. So for example, if I tell you, oh, this is 2 meters and this is 30, then what's the horizontal component? That will be 2 cos 30. And the vertical? 2 sine 30. You got the idea? Okay, write this down, all of this. Got that? No? Okay. Yeah?
Sorry, how is the second one?
Yeah? Why are you asking me?
R equals h cos theta.
Ah, so what I did was I multiplied the or from the denominator up to the left. Cross multiplying is what you call it in maths. Okay. Do you have that? Yeah? Okay. Whoops. Right. Speed can actually be defined as the magnitude of the velocity vector. So for example, if I tell you he's heading this way, and this side here is 3 meters per second, and this side here is 4 meters per second, okay? We say his velocity is equal to, well, I can just write 3 meters per second east and 4 meters per second north. But I can say his speed is equal to 5. Okay, so I think I would like you to write this down as an example too. And then once you write that down, you can write this down. Okay, you got that? Yeah? Okay. Ming, did you get your account opened yesterday?
Yeah.
Yeah, no problem.
No problem.
Who else opened their account yesterday? No problems?
Yeah.
Problems.
Ah, what went wrong? Forgot something?
But no, because the passport's brand new design. Yeah, it's not.
And that's a problem.
So it's not in the system.
They
Ah.
changed the design of the new Nigerian passports. So like they haven't seen it before. So like
Oh, so they were suspicious then? Yeah, okay. That's weird. So what did they end up doing?
Still open.
well, I think I don't know yet, but see how it goes.
Okay, it's ongoing. Right, do you have this?
Yeah.
Now write down this definition. Speed is the magnitude of the velocity vector. Okay, you got that? Right, here's our first real example. We have a vector 10 meters horizontally, 10 meters per second horizontally, along the ground and 20 vertically. What is the magnitude and direction of this vector? So you have the ground here. That's grass. And you know, normally what happens is you have something that's being thrown. And I tell you that this component is 10 meters per second, and this component is 20 meters per second. And I would like you to tell me what is the magnitude here and the direction here. Okay? So I'll give you 1 minute to calculate this. See what you can do. Okay, got the answer? Not yet, okay. So the magnitude should be this, which is what? And the theta should be this, which is what?
63.4.
Okay. Okay. Easy peasy? Yeah.
So, how do they cover the time and cost?
What do you mean?
Like, what exactly is a time? What exactly is a cost?
The way your calculator calculates it is quite difficult. So normally in the past people would use table books where they would look up cost of an angle. You know what I mean?
Like, how they develop, like, what's made it to exist?
Yeah, so previously people would just, you know, notice that if you had a triangle and if you were to say the sine is this side divided by this side, that the angle is always the same even if you make the triangle bigger or smaller. So, like for example, if I was to draw the triangle here 1 and 2, I would know that this angle is still the same. And have long table books where you can have like, you know, theta and sine theta, and you can look up the sine theta to get the theta, or vice versa. So really it works, and it comes about because triangles that have the same proportion have the same angles. So if you were to write down all the triangles, then you can get any angle, because you only need the proportions to be the same, you know. So, but the way your calculator does is actually in a very difficult way that you won't learn about until next year. Wait, what are you studying next year? You hope to study? Computer science, is it? Ah. Okay, maybe you'll never discover then. So I don't...
We might maybe like angles like for some waves. Like
Yeah, no, I was just thinking like sine and cos do make nice waves. So you might study it in more detail. Oh, no, you might, yeah. Okay. Continue. So, there's a door? Who could that be? Ah, Jason. Where were you? At the bank, was it?
Yeah.
Yeah. So, you're here for the second class. Let's see. Okay. A ship is sailing 15 kilometers per hour at a bearing of 30. Do you remember which direction is bearing? From where? No. The other one, north. And to the left or to the right? Right. I want you to get me the two components here, the east and the north, please. So what I'm looking for here, I tell you that this here is at 30 and it's 15 kilometers per hour. And I would like this component and this component. Okay? I'll give you a minute again. Okay, got the answer? Got it now? So, which one is this? The cos or the sine? Yeah, this one is 15 sine 30, because this one here is 15 cos 30. And the way to remember it is, the one that touches the angle is always the cos.
Can say just 60.
Yes, and you could do 60 as well if you like. So, what did you get for this side? 7.5
Yeah.
kilometers per hour. And this side?
12.99.
So 13. 12.99?
Yeah.
So 13.0 kilometers per hour. Yeah? Okay? Right. Continue. Yeah. Whoops. A plane can fly 200 kilometers per hour in still air. That means when there's no wind. The plane heads northeast, but there's a wind blowing at 100 kilometers per hour from the west. So, I'll draw this for you to help you, okay? The plane, you could say it heads this way, and this is 200 kilometers per hour, and because it's northeast, this is 45 degrees. But, does it stay northeast? No, because also in the story, what's happening is there's a wind from the west. So this wind from the west, that's 100 kilometers per hour. This is 200 kilometers per hour. So tell me, what will happen to the plane? Will it travel more to the north or more to the east if the wind blows it?
East.
Yeah, it'll kind of head more like this way, won't it?
Yes.
Yeah. So my question is, what is the direction and what is the magnitude of the actual velocity of the plane? The actual velocity of the plane, what will it be? Magnitude and direction. Okay, now we're getting a little harder. I'll give you a minute to try this. Yeah?
How are we looking at the plane? Is it from its plan or from its end?
Which, the red or the green?
So like, are we looking at the plane from its stop going forward, and then the wind comes from its east and west?
So what happens is, so to speak, the pilot sets a course northeast. So he points the plane northeast. And if there was no wind, he would travel northeast. But then a wind suddenly blows from the west, and all of a sudden the plane now is off course. So I want to know the new direction and the new magnitude of the flight. And the way you can picture it is, like, it's almost like, if you also can think about it, if you are swimming and then all of a sudden a wave comes along, even though you might still be pointing north, because the wave comes along, it will now change your direction. Now I'll give you a little hint. You need to resolve first. You want to see the question? Yeah. Got it? Yes, no? You think you have it, Ming? Yeah. Okay. Okay, you feel you can get it, right? That's good. You think you have it?
I think.
You think you have it, yeah? The angle is smaller than 45? Yeah. Much smaller?
No, it's like 35.
Oh, that's pretty significant. That's 10 degrees. Yeah. Okay. Let's look. So look. Firstly, the plane is like this. 200 cos 45, right? And then 200 sine 45. Now, could someone tell me what those two are? So what's 200 cos 45?
141.4.
And then this is 141.42. Then what happens is the wind blows. So all that happens is that this part gets an extra 100. So now the triangle looks like this. 241.4 and 141.4. So if we use Pythagoras, what do we get for the answer for the magnitude? What's Pythagoras tell us here? Yeah.
79.8.
So 280 then, kilometers per hour. And then what does the tan inverse tell us the theta is? 30.36? Oh, I thought you said it was 35.
Yeah.
And you said 30. But that's quite different. It is 30.
Yes, it's
Okay, all right. 30.3 degrees. Yeah? Okay, one more example for the first class, then I'll let you try your homework and then we'll start the second class in a few minutes. Can I go? Yeah. Does someone say no? Okay. Yeah. Okay. So, last example. A bird is trying to fly north, but there's a wind from the northeast. So I'll draw this for you again. So here's the bird, and the bird would like to fly north. And the bird can exert a force of 30 newtons. But there's a wind. There's a wind from the northeast. So what's happening is there's a wind blowing from the northeast at 10 newtons. So what would happen if the bird flies north? Will it travel north? No, it will move off, won't it? And it'll be heading this way now because of the wind. So what the bird needs to do is this. The bird needs to fly this way so that the wind, when it pushes the bird will actually travel north. So I need you to figure out what is this angle that will cancel the effect of the wind. Okay? And this is at 45 degrees. And it is 10 newtons. So this is 10. And the bird here can do a 30. And I need the theta here. Okay. And again, my tip is kind of easier if you find this first and then find this. Okay, now this is a little hard. I'll give you a minute to try it. See the question, okay? Oh, for goodness, I can't believe I misspelled that. There is. Should be, of course, T-H-E-R-E. There is a wind from the northeast. Oh, that's disgraceful. fix it in a minute. The bird can exert a force 30 and the wind 10. What direction must the bird head? Oh, you look confused. I think I should just do it. I think this would be best. Okay, so let's have a look here. Oh, and before I do, well, no, I'll do it first. Oh, goodness. Right. So let's look at the wind first. What's the wind doing? It's heading this way. So this would be 10 cos 45, and this one is 10 sine 45.
Yeah.
So what's that? 14. 1.4. No. 1.4? Is it? No. 7 point.
7.07.
And this is 7.07. What's after the 7?
1.
Okay? Now, this is what the bird must do. The bird doesn't want to go to the left. So it must put exactly 7.071 to the right. Why? To cancel this push to the left. It must push to the right by the same amount. Then the bird will travel north. But we don't know how much he can put to the north. But what we do know is that the magnitude should be, what did I say, 20? 30. So by using Pythagoras, we can say x squared plus 7.071 squared must equal 30 squared. What's the x? $29.15. Now, question. Will the bird, is it 29.15?
Yes.
Yeah. Will the bird actually have 29.15 to the north? No. Because why? Well, don't forget, what's also happening? The wind is pushing south. So will he have the full 29 to the north? No, he'll have 23 or whatever. Okay? But I don't really care about that. All I was caring about was getting the angle, which I now have enough information. I can say it's tan inverse what over what? 29.15 over, no, 7.071. Because that's the, in the triangle, this side is 7.071. 30 was the hypotenuse.
Using cosine.
Oh, I like to use tan. I always want to use tan, okay? Right, what is this angle? 13.6.
Is it? I'm not sure.
Seems believable. Can someone tell me the angle, please?
Because I'm using cosine, I'm not sure.
Change which number?
Yes, it's outside.
Huh? Oh my goodness! I'm terrible. 7.071 over 29.15. Thank you.
Yeah, it's 13.6.
13.6.
So the bird has to head at 13.6 to the east, and then the wind will push him back to the north. That's what's happening. So he heads 13.6 to the east, and then the wind will push him back to the north, and he'll head straight. But he won't head straight at 29. He'll head straight at about 23 or whatever. Yeah? Yeah. Now, I know that's hard, but the good news is that's the hardest. It's no harder than this, okay? So, we'll have a look at the exam questions now. You need a minute to write this down? Yeah. How many questions did I give you to do in the database? Let's have a look. Or actually, I can look here. Okay. Do you have this? Yeah? Can I close it? Closing? Okay. Let me fix my outrageous spelling mistake. Where is it gone? But